An embedded system is a combination of computer hardware and software designed for a specific function. This means that this embedded system contains a CPU or computer that specially designed for specific function that these computers can't use as a general purpose computer. Like you can, if you, as an example, if you see a PC, that it can do many things. Okay, right? You can create a Word documents, play videos, or video games. Embedded devices are not like that. They are designed to do a specific one function or several limited things. Embedded systems may also function within a larger system. The system can be programmable or have a fixed functionality. This means that let's see, if a calculator as an example, you can only do maths. These like if you take a camera, it only functionality is limited. Like so, examples are calculators, TV remotes, those electronic control units in vehicles, like so. Then if we okay, did we skip one, right? Yes. Okay. There are 3 categories. Okay. Did we skip one?
I think we skipped one slide. Yeah.
Yeah. There are 3 categories. First one is embedded subsystems. Second one, standalone embedded systems. Third one is networked embedded systems. Okay. Now, if you see what is embedded subsystems are, subsystems are controllers. Typically, they are like a small part of a larger network or larger device. As an example, the GPS controllers or the ECU, like so. They only do a specific part of a larger process. They take care of little part of it, and that's that. The second one is a standalone embedded system. They do not recommend other host computer to connect it to them. They operate as their own, like digital cameras, digital wristwatches, MP3 players, like so. Am I going too fast?
No, I think
it's okay.
Yeah, we're good.
Okay, then we come to the network systems. Network embedded systems rely on wired or wireless networks and communication with web servers or output generation. We will come when we come to the Arduino, we will see that we have a RFID project, right? That's a networked embedded system. So as for these examples, you will see the home and office security systems, automated teller machines, or POS systems, or point of sale systems. So this is the IoT, Internet of Things, that we're going to do a project about RFID tags. That project is a Internet of Things device. So IoT is an umbrella term that refers to the billions of physical objects or things connected to the internet, all collecting and exchanging data with other devices and system over the internet. So for the examples, GPS trackers, industrial security and safety, motion detectors, like so.
Saliya, let me ask a question.
Yeah.
How is the augmented reality comes to that?
The like that you wear some kind of a glass, right? That data is transferred through wireless communication, like okay, right? That image processing part, like what you see is they were detailed in like face recognition options, like so.
So you're saying all the calculation is done in a different.
Like, yes.
Okay. Okay. Mm-hmm. Mm-hmm. Okay. Thank you.
Right. Uh, now we have a little idea about what embedded systems are, right? Now we talk about all of this because we wanted to come to Arduino. Now that
Okay.
Arduino, yeah.
Sorry. 1 second. So we talked about three main topics for the embedded systems, right? Everybody got some idea? Nice. Any questions to ask before we get into the next, like the last part? Nice. Yep, Saliya, go ahead.
Okay, so now that Arduino platform can be used to develop embedded systems. There are a lot of prototyping boards. The most popular one is Arduino. So we're going to use them at these project, right? Laser project.
Yeah, Saliya, 1 second. Question, please.
I still have no idea what an Arduino system is, and everyone keeps mentioning it. So
Okay, we'll come to that in next one, right, Ajit?
Yeah, I think we'll get an introduction today.
Okay.
Let's say bit by bit come.
Okay, cool.
Nice.
Okay, right. So we're going to use Arduino in this laser project, self-balancing robot. There's another one balancing a little ball, right?
Yep.
Yeah. We're going to use Arduino platform to do all of that. So that's the Arduino platform. Then we're going to use a Node MCU in our RFID project. We're using this board because it has built-in Wi-Fi capabilities. So we're going to use a Node MCU and make a IoT device. So you can see how it goes as well. Then there's a Ajit, you guys want to do some laser modulation through MCU, right?
Yeah, right now we are doing,
I think.
right now we are doing two laser projects. One is laser modulation, and the other one is the SPI, laser SPI. For the laser SPI, we are planning to use the Arduino board, and we already bought that. For the laser modulation, we thought we can use Arduino, but it looks like the speed that you see in here, 16 megahertz, it's not enough. So one best way is to go for the Raspberry Pi.
Yeah.
So it's like a more advanced version. Maybe some of you have used it. So do you remember what's the speed, like the approximate speed of Raspberry Pi?
I guess it's more than 1 gigahertz.
Nice, nice.
Yeah.
So we are planning. Sorry, we are planning to use these three, basically, right? Mm-hmm.
Yeah. Next, there's another one called Jetson Nano, that more expensive. Usually used for image processing things like face detection, number plate detection, like so. There are another ARM series. It's also low power devices, and these boards are little inexpensive and have a lot of computational power. And then we come to the FPGAs. All other boards are not enough. Then you can build your own computer using these FPGAs. These are very expensive and tax a lot of computational power. So,
Right.
yeah.
Sally, 1 second. Who heard about this last term FPGA? Nice. Would you like to say like what kind of a thing?
We just use a Zygo board to simulate. It was like decoders and counters, which basically the FPGA had like buttons you could press, and you could program each button to like count to I guess the number like 8 with binary, right? You're using a HDL, which is like basically a programming language that's connected to the Zygo, and it simulates the circuit you've programmed.
Nice. So we have we have veteran who already used FPGAs. That's really nice. So for others, it's like so for Arduino, you have some layer already. That's a program, but in FPGA, you start with the bottom layer.
Mhm.
You program the foundation and then like go bit by bit.
Is it like it's faster? Is that the advantage?
Yeah.
Okay.
So basically, you can eliminate what you don't need.
Yeah.
Exactly. So you need like quick, fast, but it's a little complex. But
Sure. Yeah.
and we are planning to go to that next semester, next year. If you guys plan to continue deep, plan to continue to come to this group, it's like marketing point, right?
Yeah.
I didn't want to say that, but we will go through FPGAs to learn more. Okay, and any other questions? Nice. Okay, Saliya, I think that's
We come in, right?
yeah. I think that's the last.
Yeah. So there are lots of other boards out there. BeagleBone. This is you can see that black one here. This is called BeagleBone. This is from Intel, and this is from AMD. This is microchip. So yeah, if you guys can learn electronics assembly and C programming is very valuable skill. So yeah, this board, all of these boards can be programmed by assembly or C. So having that knowledge is very good thing. And if you're planning to continue your careers in embedded systems. Yeah.
So for Arduino, we are using C++ language.
Arduino uses C language. Yes, you can use C++ as well. Yes.
And FPGAs, we are using assembly.
I think you can use C or assembly. Yes.
Okay.
Assembly is all processors can you can use assembly on all platforms. That they are very fast, but take a lot of time to write the program.
Exactly. Okay. So our plan is to go step by step into these ideas. Right? So right now, Molly, she's using Arduino already in the robot, and then Jasmine, your system, we are planning to implement an Arduino for controlling the power. It's called a TTL controller. We will get into that uniquely. Right? So you will be learning Arduino and then applying that. Same with Molly, and with you, a lot.
Yeah.
Right. So straight up, that's Arduino system, and then straight up diving in. So so this is the first step. Now you guys know what's the term mean, embedded systems. And Saliya, he's an embedded system engineer, straight up.
Oh,
So that's how he bit by bit we come there. Right?
cool.
So Arduino comes under there, and that's how we like bit by bit get in there. So I think this is the end slide, Saliya, right?
Yeah.
Okay. Any questions to ask from Saliya at this point? Nice. Everybody got an idea what this means, and we will save these slides because this is good to refer back and come forth. Let me show you guys like a practical items that we have here, and then take step by step towards that. Okay, Saliya. Then anything else you like to add as the last minute discussion?
Nothing special that we'll talk about Arduino in next one, right?
Yeah, I think let's start straight up Arduino next session, right? And talk about how many pins, and then how about analog and digital signals. I think it's not too fast we are diving in, but I think we should get to that point, right? Like how many pins are there, and then what are those pins meaning, and then which one you should get. And there are two things called sensors and actuators. So what do they mean, and how to implement those? Because that's what you will be using straight up in your projects. I think almost every project will be using those. Okay, Saliya. Then we'll talk later. What?
Right. Okay. Then bye. See you guys again.
Okay.
Thank you.
Right. Okay.
Yeah, thanks a lot and have a good night. Good morning.
Have a nice day.
Thank you.